I'm very pleased to welcome Deng, who's Vice Chairman of the ETSI Special Interest Group for NFV. And he's going to talk about resilience is critical and the fact that cloud has much to contribute. So welcome, Deng. As soon as your presentation is up, I will leave the floor to you.
Okay, thank you, Annie. So first of all, I would like to, I'm the current ETSI IC MV Vice Chair. I'm pretty honored to talk about cloud native resilience today. And so before that, I can briefly introduce what happened for the ETSI MV standard. So telecom historically is mostly like black box based, and more than 10 years ago, there are leading global telecom operators. They gathered in the ETSI to establish a new standard working group, which is working on the telecom cloud for the more than 10 years. The output of this organization has been supporting more than 19% of the 5G and the 4G core network deployment. So this is a great contribution to the telecom transformations. And also, I think the core network played a very early step for the telecom operator to migrate from CT to IT. But we do, I think the core people do understand the pain from these transformations because with the IT, it doesn't really has much experience for our telecom. For example, telecom network infrastructure, they are more like the critical national infrastructure, which is very importantly, not only by customer, but also by regulatory. So they have to promise to keep the service always on and to have a certain level of the resilience or high availability. But when you look at the IT part, they are historically open source based, and also there are many, I mean, the users of the IT, they get used to retry everything and reboot everything, but that is not acceptable for the telecom part. And so when we transform from the CT to IT, I think the core network has experienced a lot of things about this kind of difference, right? So, but when that's beginning, I think the operators, they understand the importance of ETSI should play for this kind of difference. And so one of the specification has been published by ETSI standard is about reliability. The 01 is about resilience requirements. So I can talk a little bit later about this part, and after that, I mean, for this 10 years deployment, not only in 4G and 5G, the operator has get used to ask their vendors to using open source based solution, and also integrate with the standard architectures. And but they do see many differences. For example, you have different layers like infrastructure, like a operating system, you have cloud solution, virtualized platform, even management plan, you have multiple open source choice. But there are so many open source choices, but there's resilience and availability is considering differently. And when you integrate with telecom solution, you have to be very careful. Otherwise, there's some unexpected accidents might happen. So the standard in the beginning trying to help. They are trying to help operator understand the gaps of this open source, understand the user case for the resilience, for the high availability. So they wrote down the specifications to help operators understand those scenarios, those use cases, those requirements is necessary. So then, then operators, before they deploy it, they have to test those kind of scenarios, use cases, in order to guarantee. I heard many long story for past 10 years when operator transformed to the cloud. For example, they spend 4 years to get identify where the fault comes from, because there are multi-window, different layers, different open source. It's really hard to locate where the fault happens. So it's not an easy job. I think it is still people are working on this kind of topic. So that's one of the reasons. Last month, I joined 3GPP architecture discussion. There are multiple operators has proposed again about cloud native part. And there are also some proposal regarding how AI and AI agent can help these kind of directions, for example, resilience. So this I would like to talk today about one of the important pieces for the cloud native part. So first of all, before we get started, I can briefly show the cover page of the ETSI standard. And if you look at here, so the ETSI about again 2015 is about 8 years ago. They have published technical cloud resilience requirements here. So if you have time, you can look at the details. These specifications is mostly trying to help operators understand when you transform from CT to IT, then you need a serious consider the resilience requirements. The objective of this resilience requirement is they always talking about service continuity, because not only a subscribe but also regulatory, it doesn't allow you to have such kind of disruption of services. Otherwise, you're going to cause a big issue, doctor cannot the emergency call cannot be received. There's so many considerations different from IT part. The second part is about the recovery from failures. I think the historic CT solution, they have very proprietary designing for the recovery from failures. But when you hand over, migrate to the CT IT part, then you have to redesign your recovery solution. And also the solutions, there's not so much considered. Like 10 years ago, for example, the OpenStack, they doesn't support the Luma, right? So there are so many features, telecom availability features are not as supportable by the open source. And the third objective is you need to consider telecom, they cannot have just one single point of failure. All right. If that is true, then you are going to experience the large risk of the resilience and also even the availability. The first one is when you transform CT to IT, you have a multi-vendor environment. For multi-vendor environments, for example, you put the one vendor for your cloud infrastructure, and then the cloud management and also network functionality from the other vendors. And even the orchestration from third vendors. So this multi-vendor environment is pretty hard to manage and to probe, to locate the failure points. And then the next one will be the hybrid infrastructures, right? So when you migrate, because the telecom has 2G, 3G, 4G, and 5G, there's different generations might have different infrastructures. Some of the 4G, they are based on the virtual machine, and 5G, some of them are based on the virtualized container. And also, quite recently, there are also operators considering bare metal when containers. So there are hybrid infrastructure, but you need to consider the resilience. So for the resilience use case, you need to consider, first one, you need to consider, for example, the stateful and stateless services. So they are handled differently. For stateful is it's really hard. You need to synchronize some stateful information from one location to the other one. So if you look at the bottom, to your right bottom, you can look at when, for example, when you have hardware failures, you need to move your VNF to the other hardwares, and also even other hardware has a resource limitation, then you have to have some algorithm to further preempt to allow the different algorithm to allow how to they distribute this kind of resilience. And also when you design your resources and also your functionality, you need to consider the spatial distribution. And the other one is the service chaining. For example, when we design the 3GPP has a, if you look at 3GPP specification, there are more than millions of pages about the control plane. There are so many different functionality has been put on the service bus, service-based interfaces. And those different network functionality has different service chaining has been, for example, when your mobile phone would like to register or even like a mobility management. So those kind of service controlling has to go through multiple different network function. There really has a sequence of the chaining of the different functionality. So how can you guarantee such kind of resilience? These are there's other challenges for the operators. Then but the specification in this ETSI standard, they are not ready to mandate the open source to redesign their software, but they are more like propose some of the use cases and the requirements. So then when operator before they are to deployment, they have to learn these kind of standard requirements like resilience. Then ask your vendor to test those kind of use cases before they get going to deploy it. Otherwise, you are 100% trust your vendors to guarantee the availability and the resilience. So this kind of mechanisms is very important. So how can you guarantee your network function to migrate across a different system boundary? And also you need to consider how can you detect your failure and report at the different layers. For example, you have your cloud as a lowest layer for the one vendor, and then the other part like the virtual machine operating system, and in the top the different functionalities. So they all has even the bottom has hardware, right? So these kind of multiple layers, and when something really happened, how do you know where is that could be failure really happens, right? So some vendors said, okay, it's not my fault. That's other layers. They spend your like a long time, a couple of days to detect the failures case. So this is one of the challenges. I heard recently there are many operators, they are coming back for the one vendor solution in order to guarantee there's a resilient, guarantee there's reliability issues. So the third one you need to consider for the resilience is you need to consider like a failure predictions and also preventions and remediation. So this is the mandatory. There are more and more new technology has come up like AI. Like I can talk it about later. There are recent 3GP proposals to be considered. And then the other part is you look at the service network. Sometimes they are kind of overloading and also blocking core blocking conditions, right? So then how can you solve this kind of network availability issues? It's also one of the mechanisms should be considered for the resilience. So this is a specification not only as engineering, also deployment guideline for maintaining network resilience, but also they have cataloged some of the faults and challenges to impact the technical cloud resilience. So this is one of the background I would like to introduce, because I think LCMV has done a very good job for this kind of directions. the operators, you better to raise this certification because they are very important to help you to understand the challenges for the telecom operator when you deploy telecom. So after the 5G gets started, the more and more operators to talk about the cloud native part. So cloud native is not being proposed, I mean required before the 6G. I mean, when the 5G comes out, the people already said, I would like to have the cloud native solution. A cloud native solution is not only just containers, it's more like the new way of the design or deployment of software. You can consider DevOps, you can consider other microservices. So there are a couple of features has been considered. I think ETSI also has considered this kind of features. I think some of the leading operators, they really understand like cloud native, for example, as far as some of the contributors, for them, like Docomo, like China Mobile, they are Orange. I think they are still working on trying to collaborate between the standard and open source, the gap to trying to help to support the cloud native solutions. So the cloud native solution, I mean, has been proposed not only back to 5G quite recently, has been again because 3GPP recently they are proposing 6G solutions discussion. So this certification from last week, I think it's last week, right? So in Fukuoka, I mean in Japan, so there are multiple operators jointly propose to remain they're trying to adoption of the remaining cloud native features. Because they're thinking today's 5G deployment just a part of the cloud native features, but not all of them. So they are proposing something more cloud native part. So after I read their contribution, I copy some of the so this document is open on the internet. You can on the 3P website you can freely download. So I copy some of the major part to here for our reference here. So one of the requirements is a cloud native level of the high availability and scalability. I think scalability, high availability is part of the resilience. I mean, maybe not all of them, but there's some overlapping resilience requirement here. So in this specification, and they talk about in cloud native, when one of the microservices fails or goes down, immediately a new microservice is taking place to duplicating the exact function of the failed one. But when you look at the previous specification I introduced, you can look at there. This use case has been exactly been described in that specifications. So the second bullet they are talking about, in addition, when a specific microservice reaches capacity limits and a new service instance will scale and to the outage opposite happens. When the service load goes down, the running service scales by dynamically reducing the number of service instances. In addition, when a cloud native features are fully utilized in 3GPP mobile network, so all of these valuable features are completed without any service impact to 3GPP mobile network and user experience. So this kind of outage consideration and also has been considered by ETSI NP standard. So maybe they are considering, they think they are different. Maybe they are thinking they are cloud native. Because 10 years ago, in ETSI standard is mostly just telco cloud, but they are thinking maybe not yet the cloud native part. But for our understanding here is we need to seriously think about is there any really difference? Today, when you deploy cloud native, you are get rid of the virtualized machine layers. You are replace them by Kubernetes containers, and also you're adding more like the software deployment tools on top of them. So I think they are in principle they are quite similar. I don't see there a big difference. So this kind of multiple open source software has been integrated into this cloud native solution, was being considered by the ETSI MFE already. I think by those operators. So today, 3GPP 60 research directions, they are considering similar requirements regarding just adding new tools and new layers of the container. I think this doesn't really make a huge difference. The only thing we think probably we better to sit together to consider how can really the ETSI and S3PP can help for this kind of cloud native features be supported. The other thing I think in my personal view, I didn't write down here is when the 5G has been deployed, the technical cloud, I mean, when we deploy the cloud solution and also the tools, we are most deploy them in the management domain. But when you consider like a 5G control plane, there is redesigned by the SBA architecture based on the SBI interfaces. This is the service-based interfaces. But those cloud native designing are not really, I mean, natively cloud native designing. I mean, they're trying to by 3GPP to redesign the service-based solution and also function and also interfaces. So I think 3GPP doesn't have the expertise for the cloud native part, but they are continue designing their network functionalities. So the cloud native part, cloud part and cloud native part in 5G, they are mostly in the infrastructure and also management plane. But for the control plane, they are still rely on 3GPP originally functionality. They are logic, they are stateful, they are not yet stateless. So there are so many gaps compared with cloud native part. So when operators seriously consider, if you are seriously consider this kind of cloud native design, you have to get the expertise like ETSI, like ETSI MFE, like open source people to really understand the mobile communications logic. Then you can redesign the much better cloud native solution. But this is one my personal suggestions, all right? But the other part we need to consider is I think a very important part is about you need to seriously consider the resilience, not just one side of the coin, right? So one side of the coin, you can support the cloud native and you can support so many buzzwords like DevOps, like cloud native, like containers, microservices. But you seriously need to understand for the telecom operator, you need to understand resilience. You need to understand the high availability. So this is not an easy job. Most of the today open source software, they are not really designed consider such kind of high reliability. Back to 10 years ago, when the OPMV in the Linux Foundation has been founded, so we have identified many telecom requirements for this kind of high availability, resilience. We're trying to propose to the IT OpenStack community. So they are not accept this kind of requirement because this is more like a telecom ecosystem, right? So I think similarly, we cannot just look at one beautiful side of the coin. We need to look at the other side for the cloud native part, because the open source is not really seriously consider these telecom requirements, and I mean regulatory requirements, right? So and even more risky for you for the telecom operators, you are adopting multiple open source all to integrate one solution. So there is one risk in one open source, but when you have multiple open source integrated together, so you have facing much more serious challenges. So this kind of pain, I think, if you look back to past 5 years, there are so many accidents has happened in globally. I mean, operators, the most of the, I think the majority of those kind of case has happened from the core network part. The reason is the core is the first telecom component has migrated from the CT to the IT part. So they are transforming from the CT solution to the IT, this kind of open source, cloud-based, cloud-native-based solutions. But so that's the challenges that happens because of when one of the hardware failures or one of the operation fails, they cause your signaling storming, the outage of your network, the disruption of services. I think I've been working on this 15 years. I look at so many, the kind of stories. I think we need to be serious regarding for the telecom part. It's not just an easy job. We need to really seriously consider how can this be improved. So my recommendation is you need to understand the 5G's logic, and then you also need to understand ETSI specification of the resilience requirement and reliability requirement. Without these two sides of the technology, designing will be not an easy job. And the last part I would like to talk about, sorry, I didn't write down here, but I do see there are many discussion from the 3GPP recently about the agentic AI part, AI agent. So the 3GPP SA1 in this February, they are proposing AI agent definition. And in last week, 3GPP SA2 architectural discussion, they also embrace the AI agent. So I think the AI agent is different. The agent is different large language model, right? So they just more specifically the intelligence of the similar what telecom is doing today, agents, right? So they are using the large language model. They are using other tools, trying to learn the procedures of the 60, the control plane sequences. And also they understand the infrastructures. So this kind of agent needs, by borrowing different large language models, then to understand not only the infrastructure cloud native part, but also understand the 3GPP's logic. Then they can design more like a resilience or like a reliability solution. So that's one of the direction I can foresee for the future of the resilience directions. I think this is all my presentation. Annie,
Okay,
thank
well,
you.
thank you, Hui Deng. That's some really, I think, a huge number of very interesting points. But I think my single biggest takeaway from your session is that resilience, like so many other things in telecoms, it's a kind of ecosystem, and there are a lot of different parties need to come together to work on this and to move it forward. And especially as we move into the era of 6G.
Yes, I think I think last month I was in Linux Foundation summit, network summit. The one of the things they are talking about is the future. So if you look at today, the cloud native people and also LC, MP standard people, even 3GPP, 6G people, they are not really understand each other. They are not really has a chance to work together. Because of the culture, because of the telecom historically, they are relying on standard, rely on 3GPPs, ETSI, but they are encouraging operators to using the cloud native software to change their transform, to help them to transform. 10 years ago, they are transformed to cloud native. Today, they are trying to transform to the AI native. So this kind of transformation, it's not that easy. They do need the people to work together. I think telecom today, they are really lagging behind or the IT. For the cloud part already, but for the future, I think there's a chance for AI because they are not that behind, right? 10 years ago, we are just copy OpenStack, copy the Kubernetes. We just borrow from IT part and use by our telecom part. But today, AI will change, right? AI, we are not that behind with it. I think at least from some of the vendors, they are very actively, and this change so fast. So I think this is the chance to let operators sit together and also to work on the new direction.
Deng, thank you very much. It's been a great pleasure and a privilege to have you with us. Thank you very much.
My pleasure. Thank you.